In this video, we're going to be covering MySQL. We're going to be starting with the introduction of databases. Uh, and so, in terms of things we wanted to cover is that basically understanding the concept of databases, like in general. Then identify different types of databases, and lastly we're gonna go into more details about MySQL, how to install it, where does it fall under, like what type of database that is, and then we can look into some basic commands and some software, like if you want to use it locally or you want to have another GUI like workbench in order to install it and use it. So like basically starting with the introduction here, what is a database? If I can make it a little bit bigger now. Okay, how about now? so so why basically we're going to be looking into why these databases are so important and how they really differ from other ways of storing information, like how is it different from storing information in a CSV file. So imagine you have a massive library filled with organized collection of information, right? Neatly stored in books and shelves. Uh, uh, that basically essentially is a database. It's an organized electronic collection of data. So this data can be anything, like it can be numbers, it can be text, it can be text to images, it can be videos. Basically, normally it is referring to images and videos and even documents. So basically, the database is gonna have numbers or text to point us where the actual video or the document exists. So unlike an individual files or like the CSVs, or also known as the spreadsheets, databases structure and connect data in a specific way, making it efficient and reliable to store, manage, and afterwards retrieve the information. So if you want to know what are the different benefits of using the databases, I'm just going to point them here. The first one is gonna be uh, the organization. So databases keep information structured and readily searchable. Basic in the end, it's gonna save you time and effort compared to like sifting through unorganized files. Then the second one is the data integrity. So data integrity, basically it enforces data rules and constraints. So we will go into a little bit more detail in maybe the upcoming videos, where we're going to be talking about the atomicity and how these databases really help us ensure that the data has integrity and the data is going to be accurate. Then sharing, you can call it also call it collaboration. So multiple users, they can actually access and manipulate data simultaneously. That's really a cool thing about the databases. Okay, then we have then we have scalability. So databases can grow seamlessly. It can accommodate like a lot more data as needed, like, which is very different from like a spreadsheet, because that has size limitations. Then we have security. So you definitely can have the access controls and permissions within the databases, and it's gonna protect the sensitive information. Right. Okay. And then it is also a powerful analysis tool. Databases, they enable complex data analysis using tools and queries, and you can extract valuable insights. That's how it helps us analyzing the big data. Okay, now we're gonna be looking into our everyday examples of databases. So everyday examples, if I want to talk about examples, I can you can think of like an online shopping platform. You can also think that these social media platform. That's another example of uh, like uh, like where users can have profiles, they can interact and have some connections. Then the streamline or the streaming services. Then we have like the banking systems, libraries. They all are perfect everyday examples of databases. Database for these kind of systems definitely makes sense, and we should be using the databases for those systems. Now we're going to be talking about the types of databases. It's really important to understand different types of databases. So basically, databases, you can consider them as two. There are two main types. One is known as the relational database, and the other one as NoSQL databases. So when it comes to the relational database, imagine you have data which is organized in neat rows and columns. So like a spreadsheet, but on steroids. So that's the essence of a relational database. Data is stored in tables, and again with each row representing a record and each column holding a specific data. And you can think of it as like holding name, user information, user position, age, and everything, those kind of things. And the tables, they are linked through relationships, enabling efficient retrieval and manipulation of complex data sets. So there is a very structured, it's a very example of a very structured approach, which makes relational databases ideal for handling well-defined, organized data. Right. And you, in terms of the examples, you can think of as like inventory management, financial transactions, customer, like the CRMs, the customer relationship management, and then the enterprise resource planning. These are the perfect examples of relational database. Whereas the NoSQL database, right? So just remember that not all data fits neatly into rows and columns. So uh, where you do not have that flexibility uh, of like organizing something in rows and columns, like this kind of situation is going to be a great example where NoSQL is going to give you a lot more flexibility for diverse data structures. They basically do not rely on rigid relational model. So like you can think of it as a documents is a very good example. Storing data in JSON like format, right? That's an example. Sometimes we have a key value pair, simple data associations like username paired with a password. Then we have graph databases. So if you have some model where you have connections and relationships between entities, uh, so so just remember that the NoSQL is gonna really shine in the examples where you want high scalability and unstructured or rapidly evolving data, or you can think of like the real-time applications, right? So just remember, I'm gonna be writing few things when it comes to the comparison or which database to choose. The things you need to really think about uh, is that, is the data structured? That's one thing you have to question. Then the query complexity, like will you need to do a lot of complex joins in order to get your required data? Then another thing you need to ask yourself is scalability. Like, do you anticipate significant data growth or not? So these are the key factors you need to think about in order to making a decision, or like whether or not you're going to be going with for a relational database or a NoSQL database. Okay, now we're going to be coming to our topic of MySQL. Okay, MySQL. So uh, I'm gonna start with a brief history of MySQL. It was born in 1995. I think uh, like since then it has been used as the trusted RD BMS, basically stands for Relational Database Management System. It was developed by a Swedish company, and but later on it was acquired by Oracle. And then basically the main thing is that it's an open source, which basically means that it is freely available for download and modification. So that's why you will find a very vibrant community of developers and users who are using this MySQL database. So why would you choose MySQL database? Is because why MySQL? One thing is that it's a cost effective database, which basically means that it does not really have any licensing fees. So the only thing is that you're going to end up paying for the storage. It's scalable, so it's versatile and scalable. It basically caters for diverse needs, and it can be like for your small personal project to very scalable enterprise level application. Then it is very good in performance. and reliability. So very reliable, it can scale really good, it can handle complex queries. And then we have also have, as an advantage, we have a cross platform compatibility. So basically means that it runs on Linux, Mac OS, Windows, and whatnot. It runs on everything. And then we have active community support. And yeah, so when you think of, like, in terms of the real life examples, I will say that in terms of the real life examples, you can think of it's going to be a great candidate for applications which involve web development, right? You have CMS like what you call a WordPress or a Drupal. Those are going to be a great candidate for it. If you have an application where you're going to be doing commerce, yeah, it can be a great candidate for that. I think there are two M's. Yeah. And then we're gonna have like applications where you are kind of making any social media application where you want to connect the users, their posts, their profiles. And or like another great example is gonna be the data analytics. As I said, can definitely handle complex joins, those kind of things, and can get you to the data you want for greater insights. Right. So now we're gonna be talking about installing and like how we can really do that. So in terms of the installation, you can download it. Uh, you can download it from the MySQL website. Again, you need to think of, like, for this tutorial we're going to be just using this dbfiddle.com for our learning purposes. You can, if you want to install it locally, um you can go to the official MySQL downloads page, install either the regular one, try free, and or you can, if you want to use the workbench, you can do that. uh, and a few other examples are going to be if, like, you are using the GCP, the Google Cloud Platform, or you are using the Amazon RDS. You don't even have to install it locally. You can use the databases over there. Workbench is a tool which I definitely recommend using it, because that is gonna be like, if you want to visualize it instead of writing down all the commands, that can really help. Okay. uh yep. And the last thing is, like, we're gonna do a practical demonstration here of, like, how things are gonna be going. So we have a concept of database. You can always say, create me a database. It's gonna be a create database, and the name of the database, we're gonna call it YouTube tutorial. And you can put again, depending on where you are, this is an optional here, colon. uh, Again, as I said, depending on, normally the colon is, it's not never gonna complain. But let's say if you are using in Spark, or if you are using the commands, there are gonna be places where the column can put you. It's gonna be complain that you cannot put a colon in the end. But normally, if you are trying it on this software or locally, you're gonna be good with every command is gonna be followed by uh, uh, a semicolon, right? Yeah, a semicolon, not just a colon. Okay. Create database is gonna create a database, and we're gonna keep running these things in order to uh, just keep checking everything. Okay. Yep. So it didn't like the name hyphen inside the name of the database. Uh, and like what happens is like you could have like multiple databases, so you have to tell him which database you're going to be using. So we're going to say we are using this YouTube tutorial. If we want to create a table, we're going to say create table. Let's say we create a table named user, and then we're going to have an ID as a column name. We want to keep the type of that as an int. So yeah, we can have a type int, and then we can do an auto. We can do an auto increment, which basically means that I don't want to manually put any value for this column. Uh, if we are keeping everything lowercase, let's just be consistent with that. Auto increment, also that would be our primary key. Then the name of the column could be a username. We can make it of type varchar. Maybe 255 would be enough. So that would be the length which is going to be permissible. We want to make sure that no one puts a null in there, and also it needs to be unique. Then we can have an email, similar options. We want to allow it to be up to 255 characters long. We don't want the user it to make it a null, so he has to provide the value, and then the unique, and then that would be good. You can also insert some values, so I'm gonna say insert into the name of the table. You're gonna name out the columns, and then you're gonna be putting the values. Our values are gonna be like, let's say the username, I want it to be test user 1, and then it would be test underscore user 1 at example.com. And maybe another one like that with test user 2 and test user, just to see if everything looks good. And now if I want to select everything, I would say select everything from either way. You can tell him the name of the database, tutorial dot user, or just the user, as we only have one database here. So if I run it, here you go. He returned two users back with their username and the password and the ID. That's all I wanted to cover in this video. Thanks for watching.